Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, IIT-Jam, Jest and other exams related to physical science. Okay. So guys, this is the 29th lecture of the quantum mechanics. This topic was remaining, so that's why I thought to complete this chapter, this topic as well. Okay, so 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 I'm going to discuss identical particles. Okay, it's a good so it's a very good chapter. Okay, so and there are many questions which are asked in CSIR net, and that's why I decided to discuss this chapter as well. Okay, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so I'm going to start identical particle. Okay, identical particles, identical particles. Okay, so identical particles. So the properties of identical particles are same. They have same intrinsic property. Okay, intrinsic same intrinsic same intrinsic same intrinsic property, same intrinsic property. Okay, same intrinsic property. For example, they have same mass, same spin. Okay, and same charge. Okay, so these are identical particles. Okay, that is same intrinsic properties. Okay, and they are indistinguishable. Okay, they are indistinguishable. Okay, they are indistinguishable. Okay, so like they are fermion, boson, right? These are identical particles. Okay, so now fermion, guys. Okay, fermions. Fermions, like they follow a Pauli exclusion principle, right? We know, right? Fermions are like electrons. Fermions are electrons. Okay, they follow Pauli exclusion principle. I'll explain that as well. Okay, then I'll solve questions. So fermions, Pauli exclusion, Pauli exclusion principle. Okay, so they follow Pauli exclusion principle. Okay, and the wave function for fermion is antisymmetric, guys, and that is psi equal to psi space into psi spin into psi isospin. Okay, psi isospin. Okay, and this wave function is antisymmetric, guys, for fermions, right? The wave function is antisymmetric wave function. Antisymmetric, antisymmetric, antisymmetric. Okay, now similarly for boson, for bosons, so and they have, okay, this is important part, right? It's important. So fermions have half integral spin. Okay, they have half integral. Okay, so they have half integral spin. Okay, they have the fermions have half integral spin, means their spin the spin of fermions is 1 by 2, 3 by 2, 5 by 2, 7 by 2, so on. Okay, integral, so half integral spin, so they have half integral spin. Next, bosons, so they have this integral spin. Okay, integral spin, integral spin means so their spin is 1, 2, 3, 4, 5, so on. Okay, integral spin. And the wave function of boson is psi equal to psi space, psi spin, and psi isospin, psi isospin. Okay, and this wave is, this is antisymmetric, and for boson the wave function is symmetric. Okay, so they have symmetric wave function. Okay, and here this is also important for two identical particles, for two identical particles, two identical particles, psi 1 2 equal to psi, we can psi 1 2 is psi 1 1 into psi 2 2, or psi 1 2 value is psi 1 2 and psi 1 psi 2 1. Okay, psi 2 1, psi 2 1. Okay, right, and the value of psi 1 2 is psi 1 1 psi 2 2 or psi 1 2 psi 2 1, right, and they are equally probable. Okay, both are equally, both are equally probable, both are equally probable. Okay, next, and the wave function for identical particle is psi is for this. Okay, this one, two identical particle, wave function is going to be psi 1 2 psi 1 2 plus minus psi 2 1. Okay, psi 1 2 plus minus psi 2 1, psi 2 1. Okay, and also you need to understand, if psi 1 2, if it is psi 1 2 plus psi 2 1, then this is symmetric wave function. If there is a minus, then it's asymmetric wave function. Okay, if sign is this, or we can write psi. Okay, so plus sign indicates that the wave function is symmetric, and if minus sign is there, then it's antisymmetric. Okay, well, this one, so now I will do questions. Okay, the questions are important for the exam purpose. Question is, so bosons, okay, so we have five bosons in 1D box. Okay, we need to find the energy. Okay, 1D box, 1D box, five bosons in 1D box. We have to fill the five bosons in 1D box, and then we need to find the energy. Okay, so how we are going to find it? Right, 1D box, one infinite, 1D box, that is infinite dimensional box. Okay, this we know. This is 1D box. Okay, and these are the energy level, and so on. Okay, so this is n equal to 1, n equal to 2, n equal to 3. Okay, so here you can see, and it's a boson, guys. So boson, boson means fermion follow the Pauli exclusion principle, right? Not boson. So all the 5 boson you will get at the ground state. Okay, ground state. Okay, so for this energy is going to be, so this energy is, we know, right? This is going to be 5 E naught, or we can write, because we know energy is E equal to, for 1D particle box, this is pi square h cut square n square upon 2 ma square, right? Or we can write we can, so this one, right? Or we can write for this one, we can write n square into E naught, right? E naught value is pi square h cut square upon 2 ma square, right? So this is 5 E naught, right? 5 E naught. Why 5 E naught? So 1 equal to 1 plus 1 plus 1 plus 1, 1 square plus 1 square, right? Is equal to 5 E naught, or we can write like this: 1 plus 1 square plus 1 square plus 1 square plus 1 square 5 times, right? Plus 1 square pi square h cut square upon 2 ma square, right? This is 1 1 1 1 1, right? 5 E naught. This value is E naught, guys. Okay, means E naught equal to pi square h cut square upon 2 ma square, right? This is 5. So because boson will be in ground state, right? And the total energy of the system is going to be 5 E naught, right? I hope you have understood it. Simple. Next question. Next question is 5 bosons, 5 bosons, 5 bosons in 2D harmonic oscillator. Okay, 5 bosons in 2D harmonic oscillator. So 2D harmonic oscillator, right? We'll make it. This is going to, for 2D harmonic oscillator energy we know, right? That is nx square plus ny square. No, this is nx plus ny plus 1 h cut omega, right? This is the one. And so here you can see this energy is going to be, for a e equal to 0, that is going to be, for ground state energy is going to be h cut omega, 2 h cut omega, 3 h cut omega, right? And now 5 bosons in 2D harmonic oscillator means all 5 will be here, right? This is a boson, right? So energy is going to be that 5 into h cut omega, and this is 5 h cut omega. So energy of 5 bosons in 2D harmonic oscillator is going to be 5 h cut omega, right? Simple, guys. Next point. Now for first excited state, this is ground state energy. Okay, so for first excited state, what will be the energy, right? This we need to find out. So here you can see this is the same, right? This is h cut omega for 2D harmonic oscillator, 2 h cut omega, and this is 3 h cut omega, right? So there are first excited state means 5 and 4 will be here, 1 will go up, right? So the energy is going to be total energy, right? This is 4 h cut omega square, second energy is 2 plus 2 h cut omega, that is 6 h cut omega, right? This is the answer, guys. Next question. Now for fermions, okay? Now okay, for fermions you need to know this as well, okay? Fermions which will follow the Pauli exclusion principle. If so, I'll write first. Spin S equal to 2s plus 1, that is number of fermions can be filled in a level. So 2s plus 1 number of fermions can be filled in a level. It means, I'll explain. Suppose spin of fermion is given 1. So this means by Pauli exclusion, what we are 2s plus 1 will find. So 2 into 1 by 2 plus 1. So 2 will get cancelled. This is 1 plus 1. So 2 fermions will be filled in one level. Okay. Similarly, if S equal to 3 by 2, because for fermions, right, that will be half integral. Spin will be half integral, right? So this is going to be 2s plus 1 will find first. Okay, we'll find 2s plus 1 implies the 2s plus 1 is going to be 2 into 3 by 2 plus 1. 2 will get cancelled, that is 3 plus 1 means. So in a level, if spin is 3 by 2, 4 in one level 4 fermions will be filled. Okay, and similarly if S equal to 5 by 2, that implies we'll find 2s plus 1, that is means 5 2 into 5 by 2 plus 1, 2 will get cancelled, so 5 plus 1 means 6. If S is 5 by 2, then 6 electrons will be filled in one level. Okay, guys, so now we'll solve questions. Okay, so now question is, question is 5 spin 5 spin half, spin is half given. Okay, spin half, 5 spin half fermions, 5 spin half fermions, 5 spin half fermions in 1D quantum harmonic oscillator. Okay, so how to, so we need to, so we have 5 fermions, 5 spin half fermions, and we have to fill those fermions in 1D harmonic oscillator, and then we need to find out its energy. Okay, so simple, this is the harmonic oscillator energies levels. Okay, and for 1D means this is 1 by 2 h cut omega, this is 3 by 2 h cut omega, and this is 5 by 2 h cut omega, right? These are the energy levels. Okay, for ground state, first excited state, and since S is given, spin is half, right? Spin is half, it means we'll find 2s plus 1 equal to 2 into half plus 1. So this means 1 plus 1, that is 2. It means in a level we can only fill 2 fermions. Okay, so 5 fermions we have to fill in the harmonic oscillator, then we need to find energy. So 2 will be here, 2 will be here, and 1 will be here, right? So there wouldn't be more than 2 fermions in one level, right? Because we'll find 2s plus 1, and by that we'll fill the electron. Okay, so now now energy is going to be 1. There are 2 electron ground state, means 2 into half h cut omega plus 2 into 3 by 2 h cut omega plus 5 by 2 h cut omega. There is only one, 2 will get cancelled, so this is going to be 4 h cut omega plus 3 h cut omega plus 5 by 2 h cut omega, right? This is going to be this one, and this is going to be, let's solve it. This is 2 to get cancelled the h cut omega, this is 2 to get 3 and 1 4, and plus 5 h cut omega, right? So this is going to be 8 h cut omega plus 5 h cut omega by 2. That means 13 h cut omega by 2. Okay, this is the energy. Okay, next question. In the same question, now first excited state energy. First excited state for the same question. Okay, for this question, 5 boson, 5 fermions. Okay, now you can check it. So we have these electrons, right? 2 here, 2 here, and 1 here. 1 here, right? You can see these the electrons. For this, we need to find the energy. This is the energy for ground state. Now we need to find energy for first excited state. First excited state means so this is the ground state, right? So this electron, this boson can go here, right? This is the possibility, right? This will go here, right? So if this goes there, right? This is the first excited state, and now we'll get the energy. This is h cut by 2. This is h cut by 2. This is 3 by 2 h cut omega. This is 5 by 2 h cut omega, right? So the energy is going to be then the first excited state energy, because energy will go here, right? From here to here. So this is going to be, this is 2 into half first excited energy, 2 into half h cut omega plus 3 by 2 h cut omega, right? Plus this is going to be 2 into 5 by 2 h cut omega. 2 will get cancelled and this 2 will get cancelled. So this is going to be 6 h cut omega plus 3 by 2 h cut omega, right? So this is going to be 15 by 2 h cut omega. This is the first excited state energy, guys. Okay, so this is the first excited state energy. Very simple, guys. Next is 5 electrons. Question is 5 electrons in 2D harmonic oscillator. Okay, 5 electrons we need to fill in 2D harmonic oscillator. Okay, so we'll again form this energy levels. So this is this energy is going to be, now it is 2D harmonic oscillator. 2D harmonic oscillator means E is going to be this one, nx plus ny plus 1 h cut omega, right? So this is going to be for ground state, this is energy is going to be h cut omega. This is 2 h cut omega, okay, and this is 3 h cut omega. These are the energy levels. Okay, now we have to fill 5 electrons and then we need to find out the energy of the system. Okay, ground state energy. So this is going to be like this: 5 electron spin is half, means in one level there would be 2 electrons, right? 2 and 2. This is the case, then energy is going to be 2 into h cut omega plus 2 into 2 h cut omega, 2 and 2 electrons, plus 3 into 1 h cut omega, means 3 h cut omega, right? Or I'll write 1 into 3 h cut omega, that would be better. 1 into 3 h cut omega. And so this value is going to be 2 h cut omega plus 4 h cut omega plus 3 h cut omega. Here we need to understand, guys, this is not correct. So for 2D harmonic oscillator, there are degenerate energy levels. Okay, so there is zero. This is 0 0, and this is 0 1 and 1 0. So there are two energy levels. Okay, two energy levels degenerate, right? So one electron will be here and one electron will be here, right? So energy will be same, right? So this is going to be, this is good question, guys. Okay, note down. This is going to be, now 2 is there and there are three energy level, right? So 3 into 2 h cut omega. Okay, 3 into 2 h cut omega, it means 8 h cut omega, because it's a 2D harmonic oscillator, right? And for this degeneracy is 2, right? We know for every level degeneracy is n plus 1 for 2D harmonic oscillator, right? If n is 1, then degeneracy is n plus 1. Okay, if n is 1, then degeneracy is going to be 2. Okay, level is 1. Okay, guys, this is the one. Next. Next question is, next question is 9 electrons in 2D harmonic oscillator. Okay, so we have to fill 9 electrons in 2D harmonic oscillator, and then we need to find out its ground state energy. Okay, so the same, this is the energy levels. I have explained this harmonic oscillator in detail in quantum mechanics, guys. You can check my that lecture of harmonic oscillator. Okay, okay, so this is like the energy is h cut omega. I have already explained here, right? This one, h cut omega, 2 h cut omega, 3 h cut omega. Okay, so now 9 electrons. 9 means it has degeneracy g equal to 2. It has degeneracy g equal to 3, right? So this is 2. This has 3. Okay, this has 3. Okay, so here you can see 2 electrons here, 2 electrons here, 9, right? 2 electrons going to be here, right? 2 electrons here, 2 to the 4 to the 6 to 8, 2 electrons here. Okay, so these are 9 electrons, guys. Okay, so because these are two degenerate levels, so there would be 4 electrons, right? So now energy is going to be simple, right? H cut 2 into h cut omega plus 4 into 2 h cut omega, because it has 4 electrons, because its degeneracy is 2. It has 3, so plus this is 3 into 3 h cut omega. It has 3 degenerate energy levels, right? So this is going to be 2 h cut 2 h cut omega plus 8 h cut omega plus 9 h cut omega, right? So this is going to be 19 h cut omega. This will be the ground state energy, right, guys? Now next is question is 9 electrons in 3D simple harmonic oscillator. Okay, in 3D, 9 electrons we need to fill in 3D simple harmonic oscillator, right? For 3D we know this is the energy levels. These are the energy levels. Okay, and we know E equal to, for 3D, nx plus ny plus 3 by 2 h cut omega, right? So ground state energy is going to be 3 by 2 h cut omega. First excited state is going to be 5 by 2 h cut omega. This is 7 by 2 h cut omega, and it has degeneracy. Second level has degeneracy 6. Sorry, it has 3. It has 3. It has 3, and it has 6. Okay, G value, because we know the degeneracy value, right? N into n plus 1 n plus 2 by 6. Okay, so this had three degeneracy. Okay, so this here you can see. So now 9 electrons means 2 will be here, right? And it has 3 means 1, 2, 3, 4, 5, 6 electron will be here, and 1 electron. It has 6. Okay, 1 electron will be here. Okay, so now energy is going to be 2 into 3 by 2 h cut omega plus 4 into 5 by 2, sorry, 6 into 5 by 2 h cut omega. Okay, 6 into 5 by 2 h cut omega plus 7 by 2 h cut omega. Okay, so we'll solve it, and this value is going to be 43 by 2 h cut omega. Okay, very simple question. Next question. Next question is 5 spin 3 by 2, 5 spin 3 by 2 particles in 3D box, in 3D box. Okay, infinite 3D box. Okay, this we need to find out. Now guys, we know here, since spin is 3 by 2, this implies 2s plus 1 is going to be 2 into 3 by 2 plus 1. It is 3 plus 1, that is 4. Means in one energy level we can fill 4 particles, right? So this is the energy level for 1D 3D finite box. Okay, these are the energy levels. This is n equal to 1. Okay, so this is, so now the energy level. So here you can see 4 electrons and here 1 electrons, right? And also the energy of this for 3D we know, right? 3D value, and energy we know, that is nx square plus ny square plus nz square, right? Pi square h cut square upon 2 ma square, or we can write nx square plus ny square plus nz square into E naught. Value of E naught is this. Okay, simple. Now for this energy is going to be 114, right? So there are 4 electrons in 3D, right? So this is 111 and equal to 111 for it, right? So it is going to be 1, right? So it has a degeneracy, it has 3, it has 1 only, right? So this is 111 E naught, right? So this is going to be 3 E naught. This energy is 3 E naught. E naught value is this, and this energy is going to be 6 E naught, right? Because energy is this is 1 degeneracy. So here there are 3 degeneracy levels. Okay, this is 1, 2, 1, 1, 1, 2, and 2, 1, 1. Right? But there is only 1 electron. So this is now energy of ground state energy is going to be this 4 into E naught, 4 into 3 E naught, 4 into 3 E naught plus 1 into 6 E naught, right? This value is going to be 18 E naught. This is the energy, guys. Okay, well, this is the identical particle. So there is one question which is asked in CSIR net PYQ. This is which is asked in 2022. Okay, June November 2022. Okay, question CSIR net 2020. Okay, so question is spin half fermion fermions of mass m and 4m and 4m are in a harmonic oscillator, harmonic oscillator potential, potential actually, it's harmonic potential, Vx equal to half kx square, which will have lowest value of ground state energy for particle. Okay, so spin half fermions of mass m and 4m are in harmonic potential this, which will have the lowest value of ground state energy for particles. Okay, options are given: four particles of mass m. Option B is four particles of mass 4m. C is one particle of mass m and 3 of mass 4m. Option D is 2 of mass m, 2 particle of mass m and 2 of mass 4m. Okay, so this is the case, guys. Spin half fermions of mass m and 4m are in harmonic potential this, okay, which will have the lowest value of ground state energy for particle. So there are 4 particles of mass m, so we'll check for that. Okay, then 4 particles of mass 4m we'll check it for, and then 1 particle for mass m and 3 particles for mass 4m, and then 2 of 2 particle or 2 of mass m and 2 of mass 4m. We'll check it. We'll find the ground state for all 4 options, and then the minimum value will be the correct option. Okay, well, when you solve it, now first option will be option 1, 4 particles of mass m. Okay, okay, so for this, right, simple potential is given, right? That is, first I'll write this one, you need to understand. Okay, potential is given half kx square, or for particle of mass m, potential is going to be half m omega square x square. Okay, now for then energy for particle m is going to be n plus half h cut omega, right? This is for mass m. This you need to understand, guys, very important. Now for mass of 4m, v is going to be half m, in place of m you will write 4m omega square x square, right? Or we can write half m 2 omega whole square, 4m 4 omega square 2 omega whole square x square, we can write like this. Then this energy for 4m particle for mass m. Okay, for mass 4m is going to be n plus half h cut omega, right? 2 omega h cut. This is the energy, guys. These two are very important points. For 4m, for particle of 4m, okay? This is particle for mass 4m, okay? Now this is the energy. So now what we are going to do for first option we are taking, okay? Option A. For 4 particle of mass m, 4 particles of mass m. 4 particles of mass m means simple energy. Now we'll make a this one. This is 1D harmonic oscillator, right? Okay. This is going to be like for mass m, this energy is going to be h cut by 2, 3 by 2 h cut and 5 by 2 h cut omega, right? These are the energy. That is. So 4 particles means 2 will be here and 2 will be here. So energy is going to be very simple, 2 into h cut omega by 2 plus 2 into 3 by 2 h cut omega. So 2 will get cancelled. So this is going to be 4 h cut omega. So this is the energy for 4 particles of mass. 4 particles of mass, right? Now second is 4 particles of mass 4m. 4 particles of mass 4m. This is also very simple, guys. I'm going to make here this one. These are energy levels. Okay, and this energy is going to be for this E we know, right? I have already found this one. So this is n plus half 2 omega h cut, right? So for ground state energy is going to be, this is 0, right? So omega h cut, ground state energy is going to be omega h cut. First excited state, this one, this is 1 3 by 2 and this is 5 by 2 h cut, right? So 5 by this is 3 by 2 and this one 2 will get cancelled. This 3 by 2 h cut, right? So this energy is going to be 3 h cut omega, and this energy for particle of mass 4m, okay? This is 5 h cut omega, right? These are the energy. Now there are 4 particles, right? 2 will be here, 2 will be here. Energy is going to be for second option, this one 2 into 2 h cut omega, my apology, 2 into h cut omega, 2 into h cut omega plus 2 into 3 h cut omega. This is 2 particle, right? So this is going to be 2 4 6 8 h cut omega. Option B, this is 8 h cut omega, guys. Okay, now third option will take. Third option is one particle of mass m and 3 of mass 4m. Okay, now we'll check for this. So again we'll make a diagram, right? Simple diagram. These are the energy levels. This is here for this is going to be like this, right? And this is the energy for 4m is going to be h cut omega, 3 h cut omega and 6 the 5 h cut omega, right? And for mass m, energy level is going to be 1 by 2 h cut omega, 3 by 2 h cut omega and 5 by 2 h cut omega, right? So here the case, one particle of mass m, 3 mass m, 4m, right? So one particle will be here and two particles of this mass 4m will be in the ground state, right? And now one particle of mass this, right? Because three particles of mass 4m and one particle of mass m. Now energy is going to be, this is energy is 1 into h cut omega by 2, right? Plus 2 into, this is very important step guys, right? Because now there are, so in ground state there would be two ground state guys, okay? Same, one for the 4m particle and one for the half h cut omega, this one particle, right? So this, its ground state energy is going to be h cut omega and it's going to be at h cut omega. So there is only one particle, so 1 into h cut 2 h cut omega, right? The three particle, 2 will be in ground first, right? And 1 will be here. So according to Pauli exclusion principle, so this is going to be 2 into h cut omega plus 3 into 1 into 3 h cut omega. H cut omega. Now it is going to be h cut omega by 2 plus 2 h cut omega plus 3 h cut omega. If we add it, so it is going to be 11 by 2 h cut omega. 11 by, that is 5.5 h cut omega. Okay, this is now fourth option. 2 of mass m and 2 of mass 4m, right? For this is going to be, again we'll make the this one, these are the energy levels. Okay, this is, the spacing is equal guys, okay, in 1D in harmonic oscillator. I'm not able to consider equal spacing, okay? So this is again for 1D harmonic, for this 4m mass, and a ground state energy is going to be h cut omega, 3 h cut omega and 5 h cut omega, so on. And for this one, for particle of mass m, half h cut omega, and this is 3 by 2 h cut omega, and this is 5 by 2 h cut omega, right? For two particle are here, right? Two particle will be there in the ground state, because in these are, and in this ground state, this is will, this is like up, right? So I'm just showing you, and this will be 2. So the energy is going to be here 2 into h cut omega by 2 plus this is 2 into h cut omega, right? 2 will get cancelled, so this is 3 h cut omega. So which is the minimum energy guys? Option 4 is the correct, option D is the correct guys, not 4, option D, because option D has a minimum energy, that is 3 h cut omega. Option B has 5.5, option C has, okay, and option B have maximum energy, this is 8 h cut omega, and option A has 4 h cut omega. So option D is the correct. So option D has, means 2 this one, 2 of mass m and 2 of mass 4m will have the minimum energy, minimum ground state energy, okay? This one, this answer, this will be the answer guys, okay? So very simple question. This is 5 marks question, which is asked in CSIR net 2020, okay? June November 2020. Okay guys, so this is about the identical particles. So now you can solve questions related to identical particles easily, okay? So guys, I just would like to request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, thank you guys, bye now.